what is it going to look like? If I say linear equation, what's it going to look like? Yeah, it's just a line. If no one has ever showed this to you before, the word line is literally right at the beginning of the word linear, but a linear equation, it's just the equation of a line. I mean, that's it. Equation of a line. And there are different formats that can come in, so we're going to talk about all of those today. There's 3 of them. And the other thing we're just going to kind of throw in the mix with this is a linear inequality. Really, the only difference here, when you have an inequality instead of an equation, we're going to have like our greater than or equal to, less than or equal to instead of an equal sign. And when you have an inequality instead of an equation, you have to think about 2 things. You want to think about 2 choices, basically. Is the line going to be dashed or solid? And then are we going to shade above or below? So we're going to review that stuff today. And before we get into that, my first example is going to have all the equations in slope-intercept form. Does anybody remember the formula for the slope-intercept form? Yes. Okay. So y equals mx plus b. Okay, who can just raise your hand and tell me, do you remember what the m stands for in that formula? This is the slope, like your rise over run. And does anybody remember what the b stands for? Yes, y-intercept. Okay, I'm going to just kind of abbreviate intercept, just int there. Okay, now we're just going to practice putting these graphs on the paper. So hopefully, I know there's one grid on here that's not big enough, so we'll work with that in a second. But if I wanted to graph y equals 3x plus 2, can anybody just describe for me, like how would you go about graphing that? Like how would you start it? How would you find more points? What would you do if you were graphing? Okay.
You do rise over 1, so up 3 over 1. And you can also reverse that to go down the longer one.
Perfect. Okay. So 2 things real quick. She's perfect. Be real careful for me. There's always somebody that starts their graph on the x-axis. I will judge you silently, but make sure your y-intercept, that 2 for that equation, make sure you're on the y-axis. I always have somebody that goes on the x-axis. Okay, so just be on the y-axis. Okay, anytime the other thing I was going to say to you, the slope there is 3. Anytime you want to take a plain number and write it over 1, that's sometimes really helpful. And I loved how she described this. You can go up 1, 2, 3, and then over 1 to the right. Both of those are positive directions. I've got a positive slope. You can also go backwards. You could go down 3, 1, 2, 3. That's a negative direction, but left 1. So down and left, both negative directions, so that still represents a positive slope. And then if you want to or not, I'm just going to play connect the dots with my straight edge here so it looks a little bit nicer, but it doesn't have to be perfect. The more points you have, the more accurate it will be. Does anybody know, like, what's the minimum number of points I need to graph a line? 2. Okay, so you only need 2 points to make a line. And we'll do that on some of these today. Okay, now my next one is an inequality. I just have these kind of mixed together to see what you guys remember. All right, so I have y is less than 3/4 x minus 5. So before I start anything on this, I'm going to answer 2 questions before I put anything on the graph. That first question is going to be, should this be a solid line or should it be a dashed line? What do you think? Dashed or dotted or however you want to do it. So I usually just try to write that for myself so I don't forget, because I always do. And then, can anybody, if it's y is less than, and everything else is on the other side, I got the 3/4 x minus 5. Can anybody tell me, would you shade above or below to represent the function? Yes. Less than goes below, greater than goes above. All right, so when we put this on the graph, we're going to shade below. So could anybody describe for me how you would start that graph? Like, where would you go? How would you find another point? Yeah. Down 5, yep. And then what do you want to do? Perfect. Yeah. Okay. If you got positive slope, we're just going to go up 1, 2, 3, and then rise over run. So the top of the fraction, that's how you go up or down. The bottom is how you go to the right. So 1, 2, 3, and then over 1, 2, 3, 4. This is not the greatest grid I've ever created in my teaching career, so it's not going to be a situation where I can really get more specific points outside of that, but I only need 2 points to make the line. So now when I play connect the dots here, I'm going to do my best to make like a dashed or dotted line. Just means the points along this line would not actually satisfy the inequality. They're not part of the solution. Sometimes they'll call that a boundary line. And I want to shade below. And I always tell people, if you're not sure, it's not too bad on this particular example, but if you're not sure, just put your pen or pencil or whatever you're shading with directly on the line, draw straight down, and that'll show you kind of what part of the graph you need to be shading. So if I need to go below, I need to shade underneath this. Okay, and you don't have, it doesn't have to be elaborate, it's just a representation here on the grid, but all these points would work if we plugged them in for X and Y in that inequality. Okay, now I have one more, and this one's kind of weird. So I've got y is greater than or equal to negative 1/2 x. So let me just ask you first, should this be a solid line or a dashed line? Solid. I always remember if you see it, it's solid. So if your lovely inequality symbol is underlined, then if you see that, then you're going to have a solid line. This just means all the points on the line are going to be included in our solution. And greater than, we're just going to shade above the solid line when we graph it. Okay, now this is kind of tricky. Where would you start this graph? 0. Okay. All right, now how would you find another point here?
Down 1 to the left 2. Or is it just down 1 up to the left 2?
I'm glad you said, okay, so you've got a negative slope. Down and right, or you could go up and left. You just want one negative direction. So I usually tell people just go down and right for a negative slope, up and right for a positive slope. You can always go backwards. But if you have a negative slope, it should come down from left to right. If you have a positive slope, it should come up from left to right. So again, when I connect these lovely dots, we're just going to make a solid line. All these points would be included in our solution. And then this is greater than or equal to, so our shading would be above this line. And if you're ever not sure, just put your pen, pencil, whatever you're working with, directly on the line, draw straight up, and that'll tell you the part of the graph we should shade. So all those guys are in slope-intercept form. See if you guys remember the next way we can write the equation of a line. So the next one I have written down here is standard form. And this one's maybe not as common. Does anybody remember what the equation for the standard form of a line looks like? It's not necessarily as common. It has an A, B, and C in it. Does that sound, John, do you remember?
AX plus BY equals C.
Yes, okay. So AX plus BY equals C. Really, it just has your X and Y on the same side, and it's set equal to a plain number. Now, I know my shading kind of interrupted this here, but when you have standard form, the A, B, and C, this is kind of a little nitpicky thing, but A, B, and C have to be integers. So that means nice numbers, no fractions, no decimals, they have to be integers. So I've got an example right underneath here to just try and transform an equation from slope-intercept form to standard form just to practice that. But if we have any fractions involved, we'll just have to get rid of the fractions. And so we're going to practice that in a second here. All right, so all example 2 says, both of these are in slope-intercept form. I have y equals 6x plus 8. I just want to change that to be in standard form. So I want it to resemble that ax plus by equals c. Anybody know how I would do that? If I had y equals 6x plus 8, how would you put it in standard form? Okay. All right, now, usually what I do, I just put that in front of the y, right? The y is positive, so it'd be negative 6x plus the y equals 8. Do I need to do anything else? You're totally fine. It doesn't matter if it's negative as long as it's a nice number in front of it. This would be the standard form of that equation, you absolutely don't have to write this down, but your A value would be -6, B would be 1, and C would be 8. Those are all integers, so we're totally good. What would I do for the other equation here in this example if I was trying to transform -2/3 x plus 5, or y equals that? How would I put that in standard form? What do you think? Good deal. You could do this first or you could do this later, but to clear that decimal, we're going to multiply everybody by the denominator, which is just 3. Okay, now when you do that, you just think of that as being 3 over 1. So 3 times y would be 3y. 3 times that -2/3, that is just going to cancel that denominator out, so it would just be -2x. The 3 that I'm trying to get rid of in the denominator and multiplying it by 3 get canceled. And then, sorry, I should write this. I'm going to multiply everybody by 3. 5 times 3 is going to be 15. And then all you have to do to get it in standard form, we just got to move that term with the x to the other side like we did in the last example. We're just trying to follow that little nitpicky rule that we have to have integers in front of each of these variables here. Okay, they can be positive or negative, they just can't have any fractions. So if you're just trying to clear a fraction, just multiply everything on both sides by the denominator of that fraction and that'll get rid of it. All right, is anybody having a question? Now, this format is mostly used to find intercepts, which is what I have underneath here. So your y-intercept is just going to be, and this is not just for lines, this is for any graph. Y-intercept, there could be more than one. For a line, there's only going to be one, okay? It's where your graph crosses the y-axis. Okay, I'm going to slide this up just a teeny tiny bit so you guys can see this graph down here, because I'm going to point to the graph here for a second. Okay. If I am a point on the y-axis, right, up and down there, what does my x-coordinate have to be if I'm on the y-axis? 0. Okay, so this is how we're gonna use this in a second. If you are on the y-axis, no matter what type of graph you're working with, the x-coordinate has to be 0. The actual equation of the y-axis is x equals 0 because all the x-coordinates are the same. They're all 0. If you're doing the x-intercept, this is just where your graph crosses the x-axis. And that's not just for lines, but for any graph where your graph crosses the x-axis. Okay, so if I'm on the x-axis, what does my y-coordinate have to be? 0. Okay, right? Because if I'm actually on the x-axis, my y-coordinate has to be 0. So anytime you're solving for one or the other of these, if you want your y-intercept, you're going to set x equal to 0. If you want your x-intercept, you're going to set y equal to 0. So we're just going to practice that real quick in this example at the bottom. Okay, now, I don't know, this morning when we did this, people were like, what are you talking about? I don't know if they were just tired or they were lying to me. But anyway, if I want my x-intercept, right, all I have to do is set y equal to 0 in that equation. Now, what I used to do when I used to teach Algebra 1 a million years ago, probably before you were born, anyway, I would tell people, if I plug in 0 for y, right, that's just going to wipe out that term, because 4 times 0 for this example would be 0. So I would just tell people, just cover that up. Did you guys ever do anything like that? I just cover it up. Okay, so just literally cover up the term. If you want x, you want to solve for x. So I'm just going to cover up that y. I just have to solve this teeny tiny little equation, 5x equals 20. So what would the x be? 4. Now, just remember that the x-intercept is 4, so that corresponds to the point 4, 0. So I'm just going to come over, plot that point on the graph just real quick. That's all you have to do. I only need 2 points to make a line. So if I find my y-intercept, I can just play connect the dots. All right, so for my y-intercept, again, anytime you're crossing the y-axis, no matter what type of graph, your y or your x-coordinate has to be 0. So again, if I would plug in 0 for x, that would wipe that term out. So I would just tell people, we're just going to cover that up because it's going to get canceled out if I plug in 0. So then the little tiny equation If you want the y-intercept, you should solve for y. So that's what I got here. I have 4y equals 20. So what would y have to be? 5. All right. Now, remember, I plugged in 0 for x, so that actually corresponds to the point 0, 5. But if you want to just find your 5 on your y-axis, and then I'm just going to play connect the dots, and that's it. Okay. Now, if we graph this other one properly, it's going to go off the graph just a tiny bit, so please forgive. Could you just tell me, you don't have to write out a bunch of work, what would the x-intercept be for this other example I have here? And if you want your x, you could do, you want y to be 0, you can just literally cover it up. What would the x-intercept be? -3. So this would mean -3, 0. What would the y-intercept be? That's just when x equals 0. What would the y-intercept be? What do you think? Perfect, -7. Now that's going to be 0, -7, and you're going to have to forgive me because it's going to go off the graph a little bit. Sorry guys, it only goes down to 6. So I'm just going to come just down here just a little bit, 0, -7, excuse me, -3, 0, and then I'm just going to play connect the dots, and then we're just graphing from standard form using intercepts there. And I put example on here that was a situation where all of these were nice numbers. That might not always be the case. It just kind of depends on the question. So you can always use this. You might have to estimate if it's not a nice number, but you can always use intercepts to graph a line. Okay. Now, I'm going to have you look at some inequalities in standard form. So we're going to have some shading involved here. And I just want to talk to you about this just a little bit. Okay. Now, you can totally do intercepts, just like we just did, right? So, if I was going to take this very first one, and I put these so these will be nice numbers, so let me look at this. I've got -8x plus 4y is greater than or equal to 24. If I just wanted to use intercepts here, what would, let's see, what would be my x-intercept be? Yeah. -3. Okay, so -3 for my x-intercept. What would my y-intercept be? Is everyone alive? What would my y-intercept be? It's a nice number, I promise. What do you think, John? 6. Okay, thank you. Okay, now, since this is an inequality, I got to answer 2 questions, and that is dashed or solid for my line, and then shade above or below. Okay, so on this question, we have greater than or equal to, so I'm going to make this a solid line when I play connect the dots here. Okay, now, I got the line on there. Let me go through this with you just really quickly. So, some people, they don't like to do the intercepts, they like to do the algebra, and they want to get the y by itself on one side. So I want to show you that for this question. If I were to do that instead, which is perfectly fine, if you want to do it and graph it from mx plus b form, I'm just going to tell you 2 things. When you try to get y by itself, when you move the term with the x, if it started out in standard form, just go ahead and write that right immediately after that inequality symbol, because it'll look more like slope-intercept form if you do that. That 24 is positive. I'm just going to slide that down, and I'm going to put plus 24, and then I'm going to divide everybody by 4 real quick here. Now, this would give me 2x plus 6. This would be the same equation. Okay, and just to show this to you. No inequality flipped or anything like that, right? So I just had, I added the 8x and I divided everything by 4, so we were good to go. So this is greater than. If you're not sure where to shade, just put greater than goes above. You're going to put that directly on the line, just draw straight up, and that'll show you what part of the graph you want to shade. Anything above that line is going to be a solution that will work for that inequality. Okay, now what I want to show you that's different about the one next to this. Okay, if you want to just use intercepts, perfect, right? Let's see. If I cover up my y, my x-intercept is going to be 4, and if I cover up my x, my y-intercept is going to be -6. Now, no matter what, I'm going to play connect the dots here with a dashed or dotted line because it's just going to be the shaded part. It's not going to include the line as part of the solution. The reason I'm kind of pausing on this for a second, it doesn't matter, it absolutely does not matter what is in front of the x. If you're working with an inequality though, and whatever is in front of the y is negative, if I were to actually do the algebra here, right, I'd subtract 3x, I'd get negative 2y is less than negative 3x plus 12, and I end up dividing by a negative 2. So anytime you're working with an inequality, if that y term has a minus in front of it, you got to remember that would actually flip the sign over. So if you want to do intercepts, you totally can. You just got to keep in mind that that sign would flip over if there is a negative in front of the y. So keep that in mind. Anytime it's minus something y, it's going to be the opposite sign. So this is actually going to be greater than, so the shading for this one's actually going to go on top. So just be careful. You can use the intercepts. Just be mindful that the inequality symbol would flip. Okay, you don't have to go through and do the algebra if you want to use the intercepts. You just have to be mindful that that sign would flip over if you've got a negative in front of the term with the y. Is anybody having a question? Okay, now I've got one more here that has kind of a free graph that doesn't have any grid marks on it, so we're just going to practice kind of sketching on this. And we're going to write an inequality for this situation that I've got an example 5. Okay, so it says local baseball game, tickets for adults are $5, tickets for children are $3. Write and graph an inequality to model all the possible combinations of adult and children tickets the stadium will have to sell to make greater than $6,000. Okay, now it doesn't specify anything here, so just so we all have the same graph. Let me let X be the number of adult tickets, and I'm going to let Y be the number of children's tickets. Just so we have the same graph, because it doesn't define the variables for us. So we can have two different graphs that would both be correct. How could I write that into an inequality if I need the stadium to make greater than $6,000? How would you do that?
5x plus 3y is greater than or equal to 6,000.
Perfect. Okay. 5x plus 3y. I would just it says make greater than, so maybe I would just do a plain greater than symbol instead of greater than or equal to, but that's okay. I'm just worried about the structure here. Now, this one, I don't have a negative in front of my y or anything like that, right? I would tell you this would be annoying to do the algebra behind and find like the y-intercept and try to do the slope, so I would do intercepts here. Okay, so if I wanted to do my x-intercept, right, I'm just going to cover up the y. So to do that, what I'm going to do is take 6,000 divided by 5. So my x-intercept, y is going to be 0. My x-intercept is going to be 1,200. All right, kind of same thing. I would just recommend doing intercepts here. It'll be so much easier. I'm going to cover up the x because I'm going to plug in 0 for x, so that'll just cancel that out. I just got to take and divide 6,000 by 3. Doesn't matter what the inequality symbol is, that's going to be for our shading. But to actually find this, just go ahead and set those equal. So then y is going to be 2,000. All right, so I'm just going to kind of eyeball this. It doesn't have to be perfect. All right, so I'm going to maybe try, I don't know, I'm just going to try and go kind of like maybe midway across the x-axis, and I'm going to call that 1,200 adult tickets. All right, now I'm going to kind of try to eyeball farther up the y-axis in terms of the distance. Doesn't have to be perfect, but I'm going to call that 2,000. I probably went too far when I just did that, but forgive me. All right, so that would be children's tickets. All you got to do is play connect the dots, and I'm just going to do a dashed line because we want to make, it just says greater than 6,000, and greater than goes above. So I'm going to shade above this line, but I'm not going to go out of the first quadrant. Does anybody know why I'm not going to go out of the first quadrant there? Why would I not go out of the first quadrant for my possible tickets in this?
Oh, you can have negative.
Yeah, you can't like get a negative number of tickets or people or whatever. So in general, whenever you have a word problem, you're probably going to be in the first quadrant unless it's something super weird. So anytime it's got a situation, try to be mindful of that and stay in that first quadrant. Is anybody having a question? Okay, now the last thing I'm going to review with you really quick is just to actually see if you guys can write the equation of the line if I just give you 2 points. So there's kind of 2 things that I would definitely want to remember to do that. And I don't know that all the teachers use point slope, but I'm going to show that to you today. Does anybody remember, if I just give you 2 points, how do I find the slope, which is the m in our mx plus b? Does anybody remember the formula for that? Yeah. Perfect. Okay. Change in the y's, so y2 minus y1. The little subscripts are just to indicate that we've got 2 different points. And then x2 minus x1. It's the difference in the y's or the change in the y's over the change in the x. Don't have to write this, but if you want to. I had somebody write this a long time ago and I thought it was cool. So they wrote rise over run, just to help remember. They spelled rise wrong with the y like that. Just to remember that the y's go on the top, the x's go on the bottom, if that helps you in any way. Now, did we use point slope? Does that, you know that one? Do you remember it? Yeah, it depends. You're fine. There you go. All right, so, sorry, I shouldn't have put you on the spot like that. That's a very complicated equation to remember. So all you need to do point slope, and then you can transfer this into slope intercept or standard if you needed to, but I swear to you, this is the easiest way I've ever seen to write the equation of a line. Okay, and if you haven't used it, I'm going to show it to you today. So it's y minus the y coordinate of the point, slope, and then x minus the x coordinate of the point. Okay, you don't have to write this down, but if you were actually using this, you would plug in a value for the y coordinate of the point, you would plug in a value for the slope, and then you would plug in a value for an x coordinate of the point. All you need is a slope and a point to be able to accomplish using the point slope formula. So the plane x and the plane y will stay plane x and plane y, and when you simplify that, that'll give you your equation. And usually we simplify it to be in slope intercept form. Okay, so I just got 2 points. We're just going to go through this process, write the equation of the line. Completely up to you. I usually just take and label the first point that's written down in the problem, x1, y1, and the second point, x2, y2, but you could flip that, doesn't matter. And to find my slope, that's the first thing I'm going to do here real quick. I'm going to do y2, which is 16, minus y1. Now, I'm writing this out on my notes so you guys can see it, but if you are like, oh, duh, minus a negative would turn into a plus, you go ahead and write that. And then x coordinate of the second point, which is -2. If you guys are looking at this, the x and y coordinates of the same point should stack on top of each other if you're plugging this in correctly. And then the y coordinate, or sorry, x coordinate of the first point is 3. Now, on the top of that, if you do get minus a negative, which happens frequently in these formulas, that turns into a plus. So it's going to be 25. -2 minus 3, we're just getting more negative. So this would be -5. And so then if you're able to simplify that or reduce it, you want to do it. This actually becomes a nice number. It's actually just -5. Okay, so there's my slope. The only other thing I need to actually write the equation of the line is just to pick one of those points they gave me, and it completely does not matter which one. I'm just going to use the first one. So I'm just going to use the 3, the -9. Now I'm going to plug it in just like I have this formula. So it's y minus the y coordinate of the point. It's always y minus. Now in this case, again, if you want to skip this step and go, okay, I know minus a negative is a plus, you go for it. I'm just writing it out to show you for this first example. Plug in your slope, which is -5, and then in parentheses, x minus x coordinate of the point was 3. So again, if you want to just go ahead, if you know you're going to have minus a negative, and just go ahead and write that as y plus 9 to start out with, feel free. Then literally 2 steps and you've got it in slope intercept form. All you have to do little distributive property here. So I'm going to have y plus 9 equals negative 5x, and then negative 5 times negative 3 gives you positive 15. And then the only other thing you have to do is subtract 9, and then you've got it in slope-intercept form. So it's negative 5x, 15 minus 9 is going to give you 6. So that would be equation of the line through those 2 points. Is anybody having a question? Okay. Sorry, we don't have a ton of time today, but the homework is on Math Excel this evening. So